So this is a continuation on your week 1, which is lesson 3. So we're done discussing the lesson 1 and lesson 2. On your lesson 3, we have the wide area networking. So what is a WAN? The physical WAN components. What are the WAN standards? What are the T carrier and E carrier standards? The optical carrier standards. What is ISDN? And connecting to the internet with WAN components. So let us describe first what is a WAN or a wide area network. So we all know WAN is a telecommunications network that extends over a large geographic area or geographic distance for the primary purpose of computer networking. So wide area networks are established with least telecommunication circuits. So figure shows an example of a wide area network, also known as WAN. So it is a large network of information that is not tied to a single location. So WANs can facilitate communication, the sharing of information, and much more between devices from around the world through a WAN provider. So the WAN network is the internet itself. So other smaller examples of WANs are a network of a bank cash dispensers, a company network with several branch offices geographically distant. So of course, WANs can be used to connect cities, connect states, or even countries. So it is used also by a larger corporations or organizations to facilitate the exchange of data in a wide variety of industries, corporations with facilities at multiple locations, okay, have embraced the wide area networks. The service components of wide area network, okay, include the following. So first, redundant core network infrastructure, redundant high capacity access to the internet, all equipment required to interface service with customer local area network, and the IP addresses for each device, and the IP telephony, and the domain name service. So those are the service components of the wide area network. So again, a WAN is a telecommunications network that extends over a large geographic area, okay, for the primary purpose of computer networking. Then we have also the WAN components. So in physical WAN components, okay, we have bridge, router, baseline, and backbone. So the WAN consists of different components that combine together to form a wide area network. So first, we have the network bridge. So a network bridge, it is a computer networking device that creates a single aggregate network from multiple communication networks or network segments. So the function is called the network bridging. Okay? Yung tawag dun sa ating aggregate and aggregate network from multiple communications networks or network segments. So called network bridging. So bridging is distinct from routing. So ang bridges connects two or more different LANs that has a similar protocol and provides communication between the devices or yung nodes in devices nodes. So by joining yung mga multiple local area networks, bridges also help in multiplying the network capacity of a single local area network. So they operate at the data link layer. They transmit data as data frames. So what is the difference between bridge and a router? So both one components. So a bridge, it is a network device which works in data link layer, whereas the router is also a network device which works in a network layer. So through bridge, data or information is stored and sent in the form of packet. Okay. But the main difference between bridge and a router is that bridge study or scan the device MAC address. So ang router is a device that connects two or more packet switch networks or subnetworks. So it serves two primary functions. So first, it manages the traffic between the networks by forwarding data packets to the intended IP addresses. And also second function of router, it allows the multiple devices to use the same internet connection. So those are the two primary functions of a router. So it means a router, it receives information and forwards it based on what the router determines to be the most efficient route at the time of transfer. So router receives and sends data on computer networks. And then another component of one, we have a list line. So when we say list line, also refers to a dedicated communication channel. So that easily interconnects two or more sites. So actually, it is a service contract between a provider and a customer, yung ating list line. So this dedicated line ensures the continuous data flow from one point to another for a fixed monthly rate. So there are several types of these lines. We have the fiber list lines. Itong fiber list lines provide a dedicated symmetric data connection by sending light over a fiber optic cables. Then second is the DSL list line. So it is used to provide other types of low bandwidth list lines and the MPLS list line. So those are the three or several types of these lines. And then next, another component of one, we have backbone. So ang backbone or backbone network or core network is part of a computer network which interconnects networks. So it provides a path for the exchange of information between different local area networks or subnetworks, yung ating backbone. So a backbone can tie together diverse networks in the same building, in different buildings, in a campus environment or over wide areas. So it is a part of the computer network infrastructure that interconnects different networks and also provides a path for exchange of data between these different networks. So ang backbone, okay, may interconnect different local area networks in offices, in campuses, or buildings. So we have types of backbone networks. We have serial backbone type of network, the simple distributed backbone type network, the collapsed backbone network, and yung parallel backbone network. So those are the different types of backbone networks, okay? So it is a network designed with high capacity connectivity infrastructure that form the main link or backbone So connecting the different parts of the network. Okay, so of course, the network consists of various local area networks, the ones, and sub-networks. Okay, so the backbone normally comprises of high specification routers and gateways. So those are the physical one components: bridge, router, baseline, and backbone. So what are the WAN standards? So in WAN standards, we have T carrier, E carrier, optical carrier or the OCX, and the ISDN. So the networking standards. So it defines the rules for data communications that are needed for interoperability of networking technologies and processes. So the first one standard, we have T carrier. So the T carrier system is a fully digital transmission system. So developed by Bell Labs and introduced in the US in 1962 with the T1 line. So which supported the digitized voice transmission through pulse code o modulation, yung tinatawag nating PCM, and the time division multiplexing, the TDM, so which greatly increased the number of telephone calls. So T1 or the T carrier is a digital carrier signal that transmits the signal. Whereas the E carrier, of course, ito yung improved version of T carrier. Higher quality of transmission can be achieved using the E carrier system. So it can be proved by comparing the characteristics between both carriers, the length of time slot, the bit rate of TDM signal, and the type encoding, decoding, and the number of time slots per frame, etc. So that is the difference between the T carrier and the E carrier, whereas the optical carrier or the OCX. So an optical carrier, it is the standard unit of measure for the rate of transmission bandwidth for data. So being carried by the SONET, yung synchronous optical networking, SONET. So it is the standard unit of measure for the rate of transmission bandwidth. So the OCX stands for optical carrier levels. It is a set of signaling rates designed for transmission over synchronous optical network, SONET networks. So it means that the term optical carrier indicates that SONET runs over a fiber optic cabling. Okay, SONET runs over fiber optic cabling. So the fiber optic communication, it is a method of course, transmitting information from one place to another by sending pulses of infrared light through an optical fiber. So the light is a form of carrier wave that is modulated to carry information. Then another one standard, we have the ISDN. So what do you mean by ISDN? So it stands for Integrated Services Digital Network. So it is a set of communication standards for simultaneous digital transmission of voice, of video, of data, and other network services over the digitalized circuits of the public switch telephone network. So the ISDN supports data transfer rates of 64 kbps per channel. And most ISDN circuits used today are configured as 2 channels to provide 128 kbps of throughput. So it is a technical standard and design philosophy for digital networks. Itong ating ISDN, it provides high speed, high bandwidth channels to every subscribers on the public switch telephone network to achieve end-to-end digital functions with standard equipment interface devices. So the integrated services digital network. So a set of communication standards that uses the digital transmission to make phone calls, to make video calls, and transmit data and other network services over the circuits of the traditional public switch telephone network. So those are the one standards: the T carrier, the E carrier, the optical carrier or the OCX, and the ISDN. Okay, so let us proceed to lesson 4, which is the wireless networking. So we have wireless networking components, the wireless standards and protocols, what is 802.11, and securing wireless networks. So wireless network, of course, refers to any type of computer network that uses a wireless for network connection. So it is a method by which homes, telecommunication networks, and enterprise installation avoid the costly process of introducing cables into building or as a connection between various equipment location. So wireless network connects computers without using network cables. So however, there are disadvantages to using a wireless network. So in wireless networking, we have different components. First, we have wireless network adapter. We have the access point, the ad hoc network, the infrastructure network, and the SSID, or the service set identifier. The wireless network adapter, of course, allows the device to communicate over the LAN or local area network. So connecting to the internet or to other computers. So the wireless network adapters, such as those on laptop computers and tablets. So take the computer signals and convert them into radio waves that transmit via antenna. Whereas the access point or wireless access point, okay, in computer networking, it is a networking hardware device that allows other Wi-Fi devices to connect to a wired network. So what is the main purpose of a wireless access point? So an access point, it is a wireless network device that acts as a portal for devices to connect to a local area network. So it means that the access point are used to or are used for extending the wireless coverage of an existing network, and also for increasing the number of users that can connect to it. And then another component, we have the ad hoc network. So ang ad hoc network, it is a temporary type of local area network. So users can also employ ad hoc network to access the internet. So as long as the hosting device can access the internet. So this might be useful if only one small area of a location can access the internet, but multiple people need to get online in ad hoc networks. Also are created between two or more wireless personal computers together, so without the use of a wireless router or an access point. The computers communicate directly with each other. So ang ad hoc network can be very helpful during meetings or in any location where a network doesn't exist and where people need to share files. Then next we have infrastructure network. So network infrastructure refers to the hardware and software that enable network connectivity and communication between users, between devices, or between app or application or apps, between the internet and more. Typical example of an infrastructure network would be yung mga ating cellular phone networks. So they have to have a set infrastructure like network towers to function. So when to use an infrastructure network, if you can easily add more access points to boost the range. So the network infrastructure contains three categories of network components. We have devices, media, and services. Okay, so it is a part of IT infrastructure of an organization. Then another component, we have the SSID. So SSID stands for Service Set Identifier. So it is the name of your wireless network, also known as network ID. So this is viewable to anyone with a wireless device within reachable distance of your network. So it is recommended you to set your own password, okay, from your SSID or Service Set Identifier. So a Wi-Fi network's SSID is the technical term for its network name. So when you set up a wireless home network, you give it a name to distinguish it from other networks in your neighborhood. So you will see the name when you connect your devices to your wireless network, of course. So those are the wireless networking components. Okay, we have the wireless network adapter, the access point, the ad hoc network, the infrastructure network, and the SSID or the service set identifier. Then next, we have the wireless standards and protocols. So in wireless standards and protocols, we have the IEEE 802.11 for wireless LAN and the IEEE 802.16 for wireless WAN. So we all know that the 802.11, it refers to the set of standards that define communication for wireless local area networks. So the technology behind the 802.11 is branded to consumers as Wi-Fi, as the name implies, IEEE 802.11. So we have wireless LAN standards, yung mga common versions. We have 802.11a, 802.11b, the 802.11g, and the 802.11n. So the 802.11a was one of the first Wi-Fi communication standards created in the IEEE 802.11 standards family. The 802.11g attempts to combine the best of both 802.11a and 802.11b. So the 802.11g supports bandwidth up to 54 Mbps Okay, and it uses the 2.4 gigahertz frequency. Okay, and also we have the 802.11 AC. Okay, referred to simply as ito yung wireless AC natin or Wi-Fi AC, much like its predecessor, yung 802.11 ABGN are referred to as wireless ABGN. Okay, the 802.11 AC is currently the fastest available Wi-Fi standard. So offering the fastest data transfer speeds to your devices at home and work. But now we have also yung ating next generation for 802.11. Okay, the AX, the Wi-Fi 6 is the next generation standard in Wi-Fi technology. So Wi-Fi 6, also known as AX Wi-Fi or 802.11 AX Wi-Fi, so builds and improves on the current 802.11 AC Wi-Fi standard. Wi-Fi 6 was originally built in response to the growing number of devices in the world. Then another standard and protocol, we have the 802.16 for wireless WAN. So it is a series of wireless broadband standards written by the Institute of Electrical and Electronics Engineers, the IEEE Standards Board established a working group in year 1999 to develop standards for broadband for wireless metropolitan area networks. Okay, so one example is the WiMAX, a term created by the WiMAX Forum. It is an acronym for worldwide interoperability for microwave access. Okay, so the WiMAX wireless network communications technology. Okay, so the technology is similar to Wi-Fi, but provides high-speed broadband access over a larger area with less interference. So that is the 802.16 for wireless WAN. Okay, so let us move on to lesson 5. So connecting to the internet. So what is the internet? The intranets and the extranets. What is a firewall? What is a perimeter network? And proxy and reverse proxy servers. Okay, so let us define first what is the internet. So when we say internet, so we all know that internet is a vast network. Okay, it connects computers all over the world. So figure shows an example of the internet. So through the internet, people can share, of course, ng information, and we can communicate from anywhere with an internet connection. So the internet makes it possible to quickly find information. So we can communicate with people around the world. We can also manage our finances. Merong mga shop from home, online shopping, listen to music, watch videos, and much, much more. So, ang daming ways, no? Because of the internet. So, it is most commonly used today. So, the following, or we have 3 ways, no, to connect to the internet. So, first, connecting using wireless broadband, the Wi-Fi. Second, connecting using an Ethernet cable. And third, connecting a computer using a dial-up. So those are the following ways to connect to the internet. And then next, we have the intranets and extranets. So what is the difference between the two? So when we say an intranets are a group of services hosted on a network, it's a private structure. It is an internet-like service provision, whereas an extranet are similar services to intranet exposed to networks outside of the intranet, and services that require extra security measures. So an intranet, it is a private, no, a private internal and business network that enables employees to share information, collaboration, and improve the communications. Whereas the extranet also enables the business to communicate and collaborate more effectively with selected business partners, suppliers, and customers. So that is the difference between the intranets and the extranet. So intranet is a private network used by employees to communicate and collaborate. Okay. Whereas the intranet is a private network used by employees to communicate and collaborate, but they can also use the company intranet to create content, complete the work, and engage in the company culture. So an extranet is a private network. Okay. So that is the difference between the two. And then a firewall. So when we say a firewall, so a figure shows an example of the firewall, an example of internal network. In computing, a firewall is a network security. Okay, firewall security. It is a system that monitors and controls incoming and outgoing network traffic. So based on predetermined security rules. So ang firewall typically establish a barrier, okay, between a trusted network and an untrusted network such as the internet. So we have 5 different types of firewalls. We have packet filtering firewall. We have the circuit level gateway, the application level gateway, yung proxy firewall, the stateful inspection firewall, and next generation firewall. So those are the 5 types of firewalls. So firewalls, again, it is a network security device that monitors incoming and outgoing network traffic and decides whether to allow or block yung mga specific traffic based on a defined set of security rules. So it is a hardware or software that works as a filtration system for the data attempting to enter your computer or network. So ibig sabihin, ini-scan niya yung mga packets for malicious code or attack vectors that have already been identified as established threats. So that is the main functions or purpose of a firewall. Whereas the network perimeter, it is also the secured boundary between the private and locally managed side of a network. So figure shows an example of a perimeter network. So it enables secure connectivity between your cloud networks and your on-premises or physical data center networks. So along with any connectivity to and from the internet. So a perimeter network is sometimes called a zone or DMZ. So it also enable secure connectivity between your cloud networks, okay, in perimeter networks. So the boundary that is established by firewalls and other information security infrastructure to partially isolate a network or host from external threats. And then we have also the proxy and reverse proxy server. So a reverse proxy server, it is a type of proxy server that typically sits behind the firewall in a private network and directs client requests to the appropriate backend server. So ang reverse proxy provides an additional level of abstraction and control to ensure the smooth flow of network traffic between client and server. Okay, so ang traditional forward proxy server allows also yung mga multiple clients to route traffic to an external network. So like for example, a business may have a proxy that routes and filters employee traffic to the public internet. A reverse proxy, on the other hand, routes traffic on behalf of multiple servers. Okay, so let us move on to the Open System Interconnection Model, or the OSI model. So the OSI model defines the generic tasks that are performed for network communication. The OSI model, it is a conceptual framework used to describe the functions of a networking system. So the OSI model characterizes computing functions into a universal set of rules and requirements in order to support the interoperability between different products and software. So each layer defines networking tasks. Each layer communicates with the layers above and below it. Layer 7 provides services for programs to gain access to the network. The layers 1 and 2 define the network's physical media and related tasks. So in open system interconnection model, so we have 7 layers. So first, we have the physical layer. Second, the data link layer. Third, the network layer. Fourth, the transport layer. Fifth, the session layer. Sixth, the presentation layer. And the seventh, the application layer. So you need to know the 7 layers in sequence, either top to bottom or bottom to top. So there are some mnemonic phrases to help you remember the layers of the open system interconnection model. Like for example, please do not throw salami pizza away. From layer 1 to layer 7. Okay. So yan yung given mnemonic device or mnemonic phrases for you to remember the layers of the OSI model. Or yung mnemonic device ko is all people seem to need data processing. Okay? So later, magki-create kayo ng your own mnemonic device after the discussion. So the first layer is the physical. It transmits raw bit stream over the physical medium. So the physical layer, ito yung physical structure like coax, yung mga fiber, wireless hubs, repeaters. The layer 1 of the OSI model, which is the physical layer, defines the electrical and physical specifications for devices. So the physical layer defines the relationship between a device and transmission medium, such as a copper or optical cable. So it is responsible for communication of the unstructured raw data streams over a physical medium. So it also maintains the data rate, how many bits a sender can send per second, and also it performs yung synchronization of bits. So that is the first layer, the physical layer. And then next, we have the data link layer. It defines the format of data on the network. So the data link, ito yung frames, yung Ethernet, the PPP, switch, and the bridge. Okay, in data link layer. So the data link layer, or the layer 2, okay, is the second layer of the 7-layer of the OSI model of computer networking. This layer is the protocol layer that transfers data between nodes on a network segment across the physical layer. So yun nga yung mga examples of data link protocols are the Ethernet, the point-to-point protocol, the PPP, the HDLC. Okay, so those are some examples. So the data link layer, of course, ensures that all packets of information are passed on tree of errors. Okay. The data link layer is the second layer. So meron niyang 3 main functions. First, deal with transmission errors. Second, it regulates the flow of data. And third, it provides a well-defined interface to the network layer. Okay, next, third layer, we have the network layer. So the network layer decides which physical path the data will take. And example nito yung mga packets, the internet protocol, the ICMP, okay, yung mga IGMP. The network layer is the layer 3 in the OSI model, and it is responsible for connections between different networks. So the primary function of the network layer is to enable different networks to be interconnected. So this by forwarding packets to network routers, which rely on algorithms to determine the best paths for the data to travel. And then next, we have a transport layer. So the transport layer, it transmits data using transmission protocols, including yung mga TCP and UDP. Okay, yung mga end-to-end connections natin in transport layer. So ang transport layer is the fourth layer in the open system interconnection model and is responsible for end-to-end communication over a network. So it provides logical communication between application processes running on different hosts within a layered architecture of protocols and other network components. That is the transport layer. So it provides transparent transfer of data between end users. It provides reliable data transfer services to the upper layers. So the transport layer controls the reliability of a given link through flow control, segmentation, and error control. And then fifth layer, we have session. So the session layer, it maintains connections and is responsible for controlling ports and sessions. So ito yung sa synchronization and send to port, yung mga API sockets, okay, in session layer. So the session layer is the fifth layer, is responsible for establishing, responsible for managing synchronization and terminating sessions between end user application processes. So it works as a dialogue controller. So it adds synchronization points or checkpoints in data streams for long communications. So the session layer, so it controls the dialogues or the connections between computers. So it also establishes, manages, and terminates the connection between the local and remote application. And then sixth layer, we have a presentation. So the presentation layer, it ensures that the data is in a usable format and is where data encryption occurs. Like, for example, syntax layer, the IMAP, the FTP, the MPEG, and the JPEG. Okay? In presentation layer, so ito yung ika-6th layer natin in the OSI model. So this layer is also known as a translation layer. So serves as a data translator for the network. So the main responsibility for this layer is to provide or define the data format and encryption. So it provides independence from data representation, okay, like encryption by translating between application and network formats. So the presentation layer transforms data into the form that the application accepts. So this layer formats and encrypts data to be sent across a network. And then ang ika-7th layer, we have the application. So ito yung human computer interaction layer. So where applications can access the human, okay? So the application layer, ito na yung end user layer, the HTTP, the FTP, okay, the DNS. So the application layer is used by end user, of course, okay, such as yung mga web browsers and email clients. So also it provides protocols that allow software to send and receive information and present meaningful data to users. So the very top of the open systems interconnection communications model, the application layer provides services for an application program to ensure that effective communication with another application program on a network is possible. Okay, so those are the open systems interconnection model. So we have the physical, data link, network, transport, session, presentation, and application layer. Okay.